Hello, in this video, we shall be looking at measurement of physical quantity. In my earlier video, we looked at physical quantity. I advise you get the video so that you have more understanding about what physical quantity is all about. Here, we want to look at how we measured physical quantity. The first physical quantity we shall be looking at is measurement of time. Measurement of time is what we shall be looking at. Time is measured in years, months, days, hours, minutes, and seconds. So these are ways in which we can measure time. Measure time in years, months, days, hours, minutes, and seconds. The SI unit of time is seconds. SI unit of time is second. And due to wide range of time interval that one wants to measure, we need different types of clock or watches. So we measure time using watch or clock. And the type of clock or watch that one use depend on the interval, the time interval. So let's look at types of clock. Types of clock or watch and the uses. Types of clock and the uses. The first one is atomic clock. Atomic clock. Atomic clock measure very short time interval. Very short time interval in the range of 10 to power minus 10 seconds. So for measurement of very short time interval in the such as 10 to power minus 2 seconds, the clock that we use is called atomic clock. Then the second type of clock or watch that we use is digital stopwatch. Digital stopwatch. It also measures short time interval in minutes and seconds. In minutes and seconds. Digital stopwatch. So this is a digital stopwatch. It measures time in minutes and seconds. So you can see, you start it, take your reading, after which you stop and you record your time. So this is a digital stopwatch. The other one, we have the analog stopwatch. It also measures short time interval also in minutes and seconds. Have you seen an analog stopwatch before? I have one here. This is an analog stopwatch. You start it, you stop it, you take your reading. You use it to measure time. Then the third one, the fourth one, is ticker tape timer. is another type of watch or clock. It measures short time intervals well. Short time interval of about 0.02 seconds. Sorry, I don't have that to show us here, but this is another type of watch. We have another one called watch. It measures longer time this time around, longer time interval. Longer time interval. It measures in minutes, it measures in hour, minutes, and seconds. Watch, something we are all used to. This wristwatch, we use it to measure time in hour, in minutes, and in seconds. Then we have another one called pendulum clock. The sixth one, pendulum clock. Pendulum clock also measure longer time interval. It also measure in hour, minutes, and seconds. Then the last here is radioactive decay clock. And this measure in years. The age of ancient remain. So, like I told us earlier, there are different types of clock or watch depending on the time interval that we are measuring. So we have looked at it. The atomic clock, this is the time range that it is used for. Digital clock, like I showed us, analog digital, then ticker tape timer, we have watch, pendulum clock, and the last here is radioactive decay clock. So the ones that are available here have showed us the digital stopwatch, the analog stopwatch, and the watch, what we normally wear on our wrist that we call wrist watch. So the next thing we want to look at under measurement of time is a unit conversion. Unit conversion. Earlier we have seen that time is measured in year, in month, in weeks, in days, in hour, and even in seconds. And it is possible to convert from one unit to another. For instance, in a day, we have 24 hours. And these 24 hours, we can convert it to seconds. So we have 24 times 60 times 60. It will give us 86,400 seconds. So by this, we have convert from day in which we have 24 hours to seconds. So in a day, we have 86,400 seconds. So in unit conversion of time, we can convert from minutes to seconds, from hours to minutes to seconds, which is the SI unit, in whichever it is possible to convert from one unit to another. Let's look at the next physical quantity. This time around, we want to look at time. We want to look at length, measurement of length is the second one we are considering. Measurement of length. or distance. Measurement of length or distance. The SI unit for length is meter. However, there are other units as well. And in measurement, one of the fundamental things is that determine accuracy of measurement is what we call precision. And what is precision? It is the smallest division observed in a scale of any measuring device. So let's look at an instrument used for measuring length and also their precision. Instrument used for measuring length and their precision. Length to be measured. Length to be measured. Suitable instrument. And precision. I told us for every measuring instrument, that smallest division that you observe is the precision. It determines the accuracy of the instrument. So length to be measured, it's not every measuring instrument for length that we can use. The instrument that will be suitable for each measurement determine on the length, how far the length you want to measure it. So the number one here is if you want to measure several meters, which instrument do you use? Want to measure several meters. Which instrument is suitable? The instrument that one can use is measuring tape. For instance, you want to measure from the edge of this board to this. It's several meters. So you can use measuring tape. And the precision for measuring tape is 0.1 centimeter. If you want to measure several centimeter to 1 meter, which instrument is suitable? The instrument that is suitable is meter rule, and the precision is 0.1 centimeter. Let me show us meter rule. This is meter rule. As you can see, the smallest division is on it, which is the precision. This meter rule is from 0 to 100 centimeter. So if you want to measure length, several centimeter, but it's no more than 1 meter, meter rule can be employed in such measurement. Measurement that is of several centimeter, but it's no more than 1 meter, because the length of a meter rule is 1 meter. So any measurement within this range, meter rule can be employed. Let's look at another one. For measurement between 1 cm to 10 cm, what instrument can be employed? The instrument that one can use is vernier caliper. Vernier caliper, and the precision is 0.01 centimeter. Have you seen vernier caliper before? Let me show us. This is a vernier caliper. It have both outside and inside caliper. For instance, you want to measure, let's say, diameter of this pendulum bulb. Through the use of this vernier caliper, we can take the measurement. So what is the reading on it? We want to get the diameter. Can you read it out? So that is the diameter of what? This pendulum bulb. Also, like I told us, it have the inside caliper as well. If you want to measure the diameter of this beaker, you cannot carry ruler and put. Through the use of vernier caliper, it can equally be measured. You keep scrolling until it clip and you take your measurement. So look at it. What is the reading? Yes. So that is what? The reading of the diameter of this beaker. So that is how we use vernier caliper for taking measurement of what? Measurement between 1 cm to 10 cm. Also, for measurement that is less than 2 cm, which instrument is suitable? The instrument that is suitable is micrometer screw gauge. Micrometer screw gauge. And the precision is 0.01 millimeter. Have you seen a micrometer screw gauge before? I have one here to show you. So for measurement that is less than 2 cm, we can use micrometer screw gauge. This is a micrometer screw gauge. For instance, you want to measure, let's say, diameter of this, the rope of stopwatch. You can insert screw until the anvil clip to it firmly like this. Then you can take your reading on the main scale and on the tumble scale as well. So this is how we use the micrometer screw gauge for measurement. And for every measurement, it is very, very important that all our measuring instrument is set to 0 before we start measurement. Is set to 0. And why? To avoid what we call zero error. For instance, using the stopwatch, you ensure you set it to 0. It must be on 0 first before you start taking your reading, before you start it. If not, there will be error in your measurement. And that error, we call it zero error. Also, in taking a measurement, you take your reading at eye level. For instance, reading this meter row. It's not good you look at it from an angle like this. You look at it directly. And if you don't do that, it leads to an error, which we call parallel error. So there are two errors that are obvious in measurement, and precaution must be taken: the zero error and the parallel error. So during measurement, for us to have good result, one have to look directly on the readings that we are taking for us to have good result, because accuracy is very, very important for every measurement. Okay, the next quantity we want to look at is measurement of mass. How do we measure mass? Let's look at it. Mass is measured using an instrument called chemical balance or beam balance. Is the instrument that we use to measure mass. And mass is not the same as weight. Let's look at it. There is a difference between mass and weight. Mass is the quantity of matter. Let's look at the difference. Mass is the quantity of matter in a body, quantity of matter present in a body. While weight weight occurs due to the force of gravity. The force of gravity acting upon an object. Mass is due to the quantity of matter present in a body, while weight occurs due to the force of gravity acting on the body. That is one of the difference. The second one, mass is constant. You can measure mass, and when you take it to another place, it's still the same. While weight varies from one point to another. Then another difference, mass is measured in kilogram or in gram, while the unit for weight is Newton. Then another difference is mass is measured using chemical or beam balance. And it works based on principles of moment. It works based on principle of moment. While weight is measured using spring balance, it's measured using spring balance, and it works based on Hooke's law. I believe you have seen the difference, that mass is not the same as weight. So we say we measure mass using chemical or beam balance. Have you seen it before? Let me show us. This is a practical class. This is a chemical or beam balance that we use to measure mass. And how is it done? For instance, if you want to measure, let's say, the mass of this duster, you put it. Then what you do, you keep adding known mass to it until it balances. So that is how we measure. First of all, you insert the unknown mass you want to measure. You put. This is our balance. This is what we use to know whether it is balanced or not. As we can see, it depressed in this direction. So we keep adding known mass to it. This mass is 20 grams. Let's add and see. I've added. Is it balanced? No. Let's add other ones. This also 20. I've added. Okay, it's too much. Let's remove. Let's add other ones. Is it balanced? No. Oh, it's too much. So this is how you keep adding, keep removing until you attain a balance. This is our pointer. The moment it is at the middle, then we can say it is what? Balance. Like I told us, it works based on principle of moment. So this is how we use chemical or beam balance to know the quantity of matter, to know the mass of an object. Then for weight, we use spring balance. This is spring balance. We use it to measure the weight of an object. How do we do that? You attach the spring balance like this. Then you carry a weight that you want to measure and you attach to the hanger. Let's observe now what will happen. So you attach this to it. As you observe, you see, this works based on principle of what? Hooke's law. So there is a pointer here that you can use to take your reading. So what is the reading? So this is how we measure the weight of an object. This is how we measure the mass of an object. The next physical quantity we want to look at is measurement of temperature. Measurement of temperature. How is temperature measured? Temperature is measured using thermometer. And we have two types of thermometer. We have the digital and analog. Digital and analog thermometer. I have a thermometer here. This one is analog thermometer. So if you want to take measurement, assuming you have a sample here, you insert. After some time, you take the reading on the thermometer. So that is how we use this. This an analog thermometer. We use it to take a measurement of temperature. And there are the SI unit for temperature is Kelvin. However, there are other units. We have the degree Fahrenheit. There is also degree Celsius. And it's possible you convert from one unit to another. Let's look at unit conversion. Unit conversion of temperature. Unit conversion of temperature. For temperature, you can convert temperature in degrees Celsius to temperature in Kelvin by just adding 273 to the temperature in Kelvin. So we use equation 1 to convert temperature in degrees Celsius to Kelvin. Also, if you want to convert temperature also in degree Celsius to degree Fahrenheit, this is the formula that can be used. We use equation 2 to convert temperature from degree Celsius to degree Fahrenheit. Also, we can convert temperature in degree Fahrenheit to degree Celsius. Equation 3 can be used for that. Let's look at an example of how we can use this formula. Example, convert 2 degrees Celsius to temperature in Kelvin and degree Fahrenheit. This equation for us. So it's very simple. All you need to know, have to remember the formula. Then by substituting, we are giving temperature to be in degrees Celsius to be 2. So when you add it, you have 275 Kelvin. So it's as simple as this. Is it difficult? No. Then for the case of the Fahrenheit, remember the formula, bring it in, 9 degrees Celsius over 5 plus 32. So you substitute 9 times 2 over 5 plus 32. And that will give us 35.6 degree Fahrenheit. So this is very simple. So this is how we carry out unit conversion of temperature. Very, very simple. So thank you very much for watching. Please like, share, and subscribe to my channel. Watch my next video on dimension of physical quantity. We just looked at measurement of physical quantity. The next video, we shall be looking at dimension of physical quantity. And there, we shall be looking at what is dimensional analysis, what are the application of dimensional analysis of physical quantity. Thank you, and bye for now.